Hey, thank you for your attendance. Welcome back, everybody. This is the last Sunday of the quarter, so I'm going to try to get through as much as I kind of can today on the topic I want to cover, but I know I'm not going to get through all of it, so we'll just have to pick back up. I'm hoping to start back in January, although we're not certain yet of the schedule, so we'll keep you informed as that comes along. So. Last time we talked, we were talking about the power of the subterranean waters trapped below the crust. And we talked a bit about the flutter of the crust as the fountains of the Great Deep burst forth. There would have been tremendous release of this water out through a crack in the Earth's outer surface, the outer crust. And that would have produced a lot of unusual, pretty amazing effects. One of the things we talked about was something called water hammers and flutter in the crust. So the crust would actually flutter kind of like a flag does in a strong wind. And then at the edge of the crust where it came down and hit the mantle below the subterranean waters, it would have shut off the waters for just a split second, producing what are called water hammers, which would have created spikes, which would have had tremendous energy in ejecting material out from the crack. And so where we left off was we were talking about at this initial point where the crack happened, the pressure that was there would have dropped from about, from what Dr. Brown estimates, from about 372,000 pounds per square inch or higher when there were water hammers happening, to near atmospheric pressure, basically just like what we have now. You know, so all of a sudden there's this tremendous huge drop, and this would have created basically an explosion that would have happened out of this. And this is out of this crack. So this is kind of important to realize as we start thinking about, okay, what could have ejected material up with so much force that it actually ejects material up out of Earth's atmosphere and out into outer space. So that's what we're going to be kind of covering a bit today. So remember, when you have supercritical water, we had tremendous stored energy in that water. We talked about ions, and ion collisions would have added to that. This would have generated huge amounts of heat. It would have caused this to expand rapidly. The surface areas would cause instant evaporation, which causes even more expansion. And this would have added heat to the process. And also, there would have a tremendous amount of kinetic energy, which is the energy of motion. And this chain reaction allowed to occur across the entire opening of the crack. And with no atmosphere to produce any drag, these tremendous velocities would be available at this point. And that's kind of, again, what we want to talk about, is what would have created this tremendous velocity. So we just mentioned nuclear energy in the granite. I'm not going to cover that here now, because if we do, it'll greatly sidetrack where we want to go. But we will probably cover this sometime in the future. Hopefully we'll get back to it. But realize that today's radioactivity can be shown to be a result of what happens in the crust, great electrical forces that would have happened in the crust. And then again, something we wouldn't have expected at the end of the creation week would be for there to be anything harmful to human beings when God, basically declares everything very good. And so we wouldn't expect radioactive materials which are harmful to humans at that point. So what we're going to move on now to is the next section of the rupture phase. So the phases of the hydroplate theory that we had a handout for a couple weeks ago, basically where the rupture phase is the first phase, we had the flood phase, we had the continental drift phase, and the compression event, which is a part of that. And then we have what's called a recovery phase. So these are the phases, and I'm going to want to cover these in order of occurrence for the most part. Some of them happen, simultaneously, and some happen, are still happening actually. But the rupture phase is the first part, and this is what I want to talk about today. So we're going to turn our attention now to the formation of comets, asteroids, meteoroids, and what are called Trans-Neptunian objects. And also included in this discussion, again, we probably won't get to it today, unfortunately, but will be, why does the moon look the way it does? What caused the moon to be the way it is right now? So So Trans-Neptunian objects are called TNOs for short, and they're interesting too. So again, we'll probably won't get to that today either, but this will be an explanation of a lot of these things. And when we see that the hydroplate theory proposes an origin of these objects, these things in outer space, that's completely different than what evolutionary theory proposes, we'll see that there's a distinct difference here. So the evolutionary speculations that we see from the evolutionary community talking about origins of these objects is all based on speculation. As you really get into it, there's really not any real science behind it. It's all, something they speculate on, and they're just bases on guesses and sometimes really, quite honestly, the imagination. And this is an all too familiar aspect of what you uncover when you look deeply into evolutionary theory. You find that this theory is based on guesses and then hunches that are based on preconceived starting assumptions. And that basic preconceived starting assumption that evolutionary theory starts with, the real basic root of all this, is that everything has to have happened out of natural causes only. In other words, they automatically exclude that there's anything supernatural. There's no God. Everything has to be completely explained in the complete absence of any kind of supernatural. There's no creator. And this is commonly called materialism. And we find that this bias, it's not scientific. Again, there's reasons for this that go back into the days of Darwin that I won't cover now, but it leaves you into error, basically. It leads you into assuming things that you just can't make assumptions on. It's not how science works. So it excludes the notion of there being a super intelligent creator that's responsible for the amazing complexity and the scope of our entire universe. I mean, you look at our universe; it's absolutely enormous. It's huge. It contains unbelievable complexity, and it leads you down to the path of assuming things that are impossible are possible. Just one short example of that is the origins of life, origins of living things. Origins of living things are extraordinarily complex. I mean, we now have the ability to look deeply into cells and organic materials. We see that they're just impossibly complex. This will be something I'll cover in another course as well. But this complexity is so out there and so unbelievably complex that the thought of any random arrangements of chemicals producing living things is mathematically impossible. It's not even logically possible. So the thought that life came from non-living chemicals is basically, it's absurd. But with evolutionary theory, with your beginning assumption that there is no creator, you have no choice. I mean, you have to assume that these things happened somehow, out of randomness. So this beginning error of there being no creator forces you to more and more errors, and errors build upon errors upon errors. And once that happens, unfortunately, it gets entrenched in the scientific community. Once it's entrenched in the scientific community, it's virtually impossible to get rid of. And now it's being used to indoctrinate our children, and that there is an answer, that there's basically a universe here that created itself out of nothing, and therefore you don't need a creator. And that's a whole other subject I don't want to get into right now, but I think that's the cause of a lot of our problems that we're having in our world. So if we go back now to what we're going to talk about, which is the origins of comets, asteroids, meteoroids, and trans-Neptunian objects, the evolutionary scenario in the textbooks basically gives us two possible explanations for these objects. And I'll explain to you what these are as we go through this a little bit. But they're either one, they're remains of an exploded planet, or they're the remains of a planet that failed to completely evolve. So this is kind of where they think these objects out in our solar system come from. So we're talking about these objects in our solar system, and comets will go out of our solar system and then return. But or some will. But the experts in the field of this recognize there's significant problems with this thought that they're the remains of an exploded planet, or that they're the remains of a planet that failed to evolve. They're just puzzled by this. They recognize that there's significant problems with these explanations, and they're puzzled by them. So, for example, the most popular explanation for the origins of asteroids today is that they're bodies that did not merge to become a planet. And never explained is how, in the nearly empty outer space, matter somehow coalesces together from these rocky bodies to form asteroids. Asteroids are actually clumps of rock. We'll get into that as well. So out in outer space, things don't come together. They expand. There's special circumstances that would be needed for this to occur. And we'll see that the hydroplate theory and the bursting forth of the great deep provides these unique conditions in order for these bodies to form. So today, collisions fragment and scatter asteroids, just the opposite of what would be thought of in this failed planet explanation. And during the 4.6 billion years that evolutionists say that asteroids have existed, asteroids would have had so many collisions that they should be more fragmented than they are today. And then the only other option that really exists to explain them is that we have a special creator that created them that way. During the creation week, he tells us that he does this during the creation week. However, the comets, asteroids, meteoroids, and trans-Neptunian objects would not have been part of the original creation, as we discussed earlier in the class, since certain aspects of these items basically would be potentially harmful to humans. We've had asteroids, for example, that have struck the Earth that caused damage. So God wouldn't have declared that, I don't believe, exceedingly good at the end of the creation week. So we find later that these would logically form, and we can show scientific evidence that they would have logically been formed as a result of the Great Flood event. So again, I think as Christians, maybe we don't really stop and realize how significant and how much of an effect the Great Flood had on our universe and what it's done to our planet. And that's, again, one of the reasons I want to go through this information here. And the hydroplate theory we're talking about offers really a complete but quite different solution to these answers, to these questions, and provides the answers. So what could be a scientifically sound origin for these objects? It's when the fountains of the great deep burst forth, as described in Genesis 7:11, and the amazing forces that occurred when this happened would have launched rocks and muddy water out into our atmosphere, but as we'll see, out beyond our atmosphere into outer space. The forces that would have been necessary to do that are ample because of the energy in this subterranean waters. So we do see that there's a great deal, of course, of rain that comes back down to our surface of our Earth. This is this torrential rain that was the Geshem rain we talked about earlier. This lasted, of course, the 40 days and 40 nights. This provides the water now to completely cover the Earth as it was, during the flood and prior to the flood. But some of this material would have had, again, enough velocity to be launched out into outer space. And the escape velocity necessary to launch something from Earth out into outer space is approximately 7 miles per second. So it has to be that or higher. But the calculations that Dr. Brown has done shows that the energy released during the bursting forth of the great deep would have been clearly sufficient to have done this. He's calculated the explosion of the fountains would have produced speeds of these objects of around 32 miles per second, or even higher, which is over 4 times what the minimum speed would need to be in order to be able to eject material out past the Earth's atmosphere and the Earth's gravitational forces. Heavier rocks then would merge to become asteroids, and smaller particles, primarily water, merged with smaller particles would become comets, and they would have unusually larger orbits than asteroids have. But there's kind of no sharp line that really separates or distincts asteroids and comets from each other. In fact, some comets are also considered asteroids, and some asteroids are also still considered to be comets. So it would not be surprising in this scenario that asteroids and comets would have so many similarities, right? Because they're formed by similar processes from rocks and water launched from the fountain to the great deep as the flood begins. So the Hydroplate theory estimates that around 2 to 3% of the Earth's total mass was launched in outer space beyond the Earth's atmosphere during the flood event. So it's a pretty large amount of material, and it's not obviously enough to deplete the Earth, but I mean, that's a pretty good amount of material. So we'll discuss how these particles then soon formed to become these asteroids. Again, unique circumstances would have had to have been there, and the Hydroplate theory and the bursting forth of the great deep provides exactly the right circumstances for these bodies to form. So astronomers have tried to describe some of these things as some kind of an exploding planet. You know, again, evolutionists won't see this. They'll think that they're just remnants of some exploded planet or some planet that failed to form. But they're not realizing that they're probably standing on the 97% of the planet left that actually did explode. Okay? Apparently they're too close to be able to actually even see it. So the formation of comets, asteroids, and meteors, and interstellar dust and trans-Neptunian objects is another one of those aspects of evolutionary theory, again, they can only guess on, and the Hydroplate theory is going to provide some scientific explanations of the forming of them. But let's talk just a little bit about what they're made out of. So first we know, and it's been observed, that we know comets are made out of about 38% water in the form of ice. And we'll talk a little bit more about comets in just a moment here. And asteroids are sometimes called minor planets and are loose collections of smaller rocks, and they're held together by water and ice. Most of them are found orbiting between Mars, the fourth planet from the sun, and Jupiter, which is the fifth planet of the sun, from the sun. So that's where the asteroid belt is. Not all the asteroids are there, but this is where the vast majority of them are. And just in case you want an easy way to remember what order the planets are from the sun, does anybody know the exact order of the planets from the sun? You remember? Okay, there's a couple of kind of funny little sayings you can say to kind of remember it. One is, my violent evil monster just scared us nuts. So what that means, that corresponds to the first letters of those planets. So the first planet is Mercury, my. Venus is second, violent. Earth is evil, just in our little scenario, right? Jupiter is just, Saturn is scared, Uranus is us, and Neptune is nuts. So my violent evil monster just scared us nuts. There's actually several other ones too, but that was one of the funnier ones, I thought. But anyway, if that helps you kind of remember the order of the planets. But according to evolutionary theory, most asteroids claim to have been remnants of the early formation of our universe some 4.6 billion years ago. But again, we'll reveal soon that this formation could not have occurred unless there were special circumstances allowing their formation. So again, evolutionists claim that our solar system consists condensed out of a vast cloud of swirling dust. But we'll see, gas and dust clouds will expand away from each other, which really makes it impossible for this dust to actually clump together to form these bodies. But we'll see, again, some solid evidence that supports the source of these asteroids being from the unusual characteristics that match exactly the special circumstances that are provided by the Great Flood and the bursting forth of the Great Deep. So, and significantly, these objects have also been found to contain salts, and salt, of course, we're familiar with, and what are called silicates. And silicates are a class of chemical compounds that contain silicon and oxygen atoms in their various structures. And these compounds are the foundations of the Earth's crust. Not surprisingly, right? Would you expect that? If the Earth was the origin of this, that's what they would be made out of? These compounds are the foundations of the Earth's crust, makes up about 90% of our Earth's crust. And so I want you to keep that in mind as we discuss this further. They also contain crystalline silicates in which the silicon and oxygen atoms are arranged in a highly ordered three-dimensional repeating pattern. So common examples of this would be quartz and feldspars and what are called micas, which are different types of rock they contain this crystalline type patterns. And the formation of these arrangements requires special conditions. So these conditions are uniform temperatures above 1300 degrees Fahrenheit and slow cooling under pressure in order for these silicon structures to grow. However, in outer space, this doesn't occur. In outer space, there's no temperatures above 1300 degrees Fahrenheit, and there's no pressure that would allow these to grow. So realize absolute zero is the coldest possible temperature, and it's 459.67 degrees below Fahrenheit. This is where there's absolutely no heat. And it seems like it would be hard to imagine in outer space where it's basically virtually zero, absolute zero, for there to be a temperature above 1300 degrees Fahrenheit where the temperature is necessary to have these things form. So there's also no pressure in space, another condition necessary to produce these or form these silicates. So if evolutionary theory is correct, how would these possibly form in the vastness of space? Limestone and clays are also found, which require a body of liquid water to form. And more information on the vast amount of limestone that we'll talk about further on when we get to talking about the stratolayers in future class. But they contain limestone and clays, again, something found in abundance here on Earth. Another interesting discovery was made in 2011 when the material cubanite was reported in comet Wild 2, and it's spelled wild 2, W-I-L-D, but it's pronounced Wild. And it's named after a Swiss astronomer named Paul Wild, and he discovered this comet in 1978. But cubanite is a relatively rare mineral found at high temperature ore deposits and only forms in scalding hot water between 122 degrees and 392 degrees Fahrenheit. So cubanite was found in samples collected by NASA's Stardust mission from a comet when they went out and they collected samples from this comet. It's pretty amazing they can do that. But they collected dust grains from the comet in 2004 and returned it back to the Earth in 2006. And the presence, its presence of this cubanite in these collected dust grains provides evidence that pockets of liquid water existed on the comet at some point. And this is a surprising discovery, too, for what would be expected in comets. And why would that be? The comets don't reach these temperatures in order to be able to form cubanite. It would be required to have these temperatures to form cubanite. And how could they have formed in the absence of water? Again, it's another example of something that shouldn't be there. I mean, it shouldn't be there according to evolutionary theory, and they're always surprised by these discoveries. I mean, this is always a surprise to them. But the hydroplate theory, again, will provide us a scientifically sound explanation for this. Comets, asteroids, and meteors also contain olivine, which is a common silicate material of the Earth's crust and mantle. Again, another thing that you expect if it came from the Earth. So olivine is named so because of its color. It has kind of an olive green type color. And it's concentrated with iron nickel in some meteors. And also iron nickel alloys found in meteors produce what's called a Wildenstein pattern, showed in the inset on the screen here. So this is a pattern is a unique crosshatched design of interlocking nickel and iron crystals found on the etched surface of iron meteorites. And this pattern only, again, forms in a uniform temperatures of at least 1300 degrees Fahrenheit. So how'd they get there? How did they form? Okay, outer space doesn't have these conditions. The conditions in the great deep are strikingly similar to many of these seemingly surprising surprising followings. And finally, probably the most perplexing part of all this is organic compounds are found, like amino acids and bacteria. So organic compounds, again, are from living things, okay? And are the basis of life, containing complex molecules like carbohydrates, lipids, proteins, and nucleic acids, and hydrocarbons. So these complex molecules, like amino acids and even bacteria, are found in these objects. It's beginning to sound like, with all these unique factors that are found on these bodies, that, you know, they might have an earthly origin, right? I mean, all this stuff comes from the earth. We can observe that. So, of course, without question, the Earth's surface has, of course, the highest known concentrations of these familiar products of life. You'll see here now, the green line on top of our plate there is plentiful organics, right? What do we have on our surface of our planet? What would there have been prior to the flood? I think prior to the flood, most of the entire surface of the Earth that wasn't, you know, water, would have had huge amounts of vegetation on it. There would have been tremendous amounts of complex organic compounds that are found in life. So where else does this form and thrive? Now, of course, they'll tell us, and you'll see this, that these objects are bringing that here from somewhere else in the universe, okay? And somehow that seeded life here on our planet. Right? That is, I mean, there's no science behind that. So often bodies are explained as the leftover building blocks of our solar system and the universe. But that's kind of like saying the field is the origin of some rusted scrap metal that you find in this field, and therefore must have formed the building that's sitting in the center of the field, right? You know, all these possibilities should be considered, but this probably suggests it's more likely that this material found in the field is probably leftovers from the building project, right? So, while there's a lot of speculation about the origin of these objects and the content of their trace organics, the evidence strongly suggests we are standing on the source of where these things came from. Okay? Now, what I want to do is show you a video. And this is very interesting. Now, listen to her. She's funny. I mean, she's like so excited about this. And listen to what she says and how excited and surprised she is to have found these objects on an asteroid. So they've sent a probe out to an asteroid to collect samples, and this is what she talks about that they brought back.
Truly insane and announced this morning. Scientists sent a spacecraft to an asteroid 63 million kilometers away, grabbed a chunk of it and brought it back to Earth. And they've analyzed the sample, and the results of what is on this asteroid are in. Basically, scientists think that this asteroid used to be part of a much bigger object, like an ancient planet or moon in the early solar system, and this chunk broke off from it. On Earth, life uses these 20 amino acids to create proteins. They found 14 of these 20 amino acids on this asteroid. So you know these 5 nucleotide bases used to make DNA and RNA? Guess how many of these 5 were discovered on the asteroid? All of them. They found all 5 of the building blocks for DNA and RNA on this asteroid. They also found 11 different minerals that form as water-containing salt evaporates. Salt water. It's also rich in carbon, nitrogen, and other organic compounds that are essential to life as we know it. All of this means that the object that this asteroid came from had the building blocks for life and probably a salty ocean. It was probably an ancient ocean world, and this asteroid is just a messenger carrying on its history. It's also possible that asteroids just like this are what brought life to Earth in the first place. Breaking space news, absolutely insane, and announced this morning.
Okay. This is the way evolutionists think, right? All right. Now, I want you to watch another video. This one is from some people who are at an organization called Real Science Radio. These are people that are going to critique what she just said, basically. They are believers in the Hydroplate Theory. These are some of the leaders. And watch their reaction to her
Production effort.
watching this video.
Yeah, she gets the raise, I think. Yeah.
Well, what everyone just saw.
Let me bring this.
It is also covered in a mineral called serpent.
Sorry about that.
So let me know what you think.
This is the most insane space news in a really long time. This asteroid called Bennu is 63 million kilometers away. That's 160 times farther than the moon is. Over the last few years, this spacecraft called OSIRIS-REx traveled all the way there, touched its surface, grabbed a sample, and brought it all the way back to Earth. And what they found in that sample is insane. It's rich in carbon, nitrogen, and organic compounds, all of which are essential to life as we know it, but we've seen that before. The asteroid is also covered in a mineral called serpentine, which looks like this. And these samples look just like the type of rock that we find here in mid-ocean ridges. This is where the stuff from the mantle of the Earth comes up and touches the water. It's underwater. Scientists think that this asteroid could be a chunk of an ancient small ocean world. This could be a piece of an old watery planet that's been traveling through space for billions of years, and we just took a sample of it.
Wow.
What do you think of that?
Wow. Oh my goodness.
We have a few minor tweaks for her. You know, first of all, that watery planet, let's call it Earth,
Oh,
as
yeah.
Kevin Lee likes to say. I wanted to get your reaction, Brian, because when I saw that, I'm like, wow. She works for Walt Brown and Real Science Radio and creating a short for us without us having to do all that production effort.
Yeah, she gets the raise, I think. Yeah.
Well, what everyone just saw on display was an example of a victim of the government schools, a victim of the deceptions and the errors that Brian has uncovered. That girl, to not even consider that this giant water planet is Earth, but that it's been traveling through space for millions of years, is because she has been victimized by exactly what Brian's been uncovering. And it's actually sad. It's sad to see, but it is instructive as to the work we have to do.
Yeah, it really is sad when you really start to think about it.
It's not be like the world. I'm gonna tell y'all something. As born again people, you can't go to heaven.
Yeah, it really is a shame that our schools are teaching this to our children. So anyway, we'll talk just a little bit about comets for a moment here. We want to discuss a little bit about what comets are and how they operate. So I presented a little bit of this material earlier, but I want to kind of go over this just a little bit here, again, just for a little bit of review. So comets are probably the most spectacular, dynamic, mysterious bodies in our solar system, and the fear of comets as omens of death and catastrophes existed in many ancient cultures, and they were called comets. Basically, they were called disasters, which basically come from the Greek word dis, meaning evil, and aster, which means star. So it meant evil star. So the combination of those two words. So comets are in an elliptical orbit around our sun, and then when closest to the sun, some comets will travel at more than 350 miles per second, and others at the farthest point, when they are reaching their furthest point away from the sun before they start to come back, can travel as slow as about 15 miles an hour. And some of the comets travel so fast that they escape the solar system and they're gone forever. So they're just out. And a typical comet, basically, as we talked about, is basically a dirty, misshapen snowball. It's usually a few miles across, contains almost nothing. It's almost just vapor. And about 38% of its mass is frozen water, but the fluffy ball contains a lot of space between these particles. So, and the rest is basically dust and some various chemicals. So how can we determine what these chemicals are and how they're made out of, what they're made out of? And there's a lot we still don't know about comets, but light from a comet tail can be analyzed. And when we do, we can identify some of the molecules and compounds that they're made up out of, since each molecule absorbs and gives off different types of light. So using this method, they've been able to determine they contain carbon, oxygen, hydrogen, nitrogen, and even remarkably, again, organic matter. So this matter, of course, comes from the remains of things such as plants and animals, things that were once living. So they contain trace amounts of amino acids called glycine, which is a complex building block of life, and also methane, which is also something that comes from Earth. So on Earth, bacteria produce almost all the methane. So the question would be, how could comets thought to have originated in the outer reaches of outer space contain high concentrations of these compounds? It doesn't make sense. Earthly scientists discovered other types of organic material in comets similar to organic material or matter of unquestioned biological origin on the Earth. So remember this. This, again, is very significant. Remember this amazing similarity to organic matter found on Earth today. A popular belief, again, is that somehow this seeded life here on Earth. They never consider, like we just watched in that video, that the Earth may be the source of this. Okay, this never seems to dawn on them. So, but I think we have evidence that comets may contain traces of this life similar to what's on Earth because they came from the Earth. So, our primary discussion is talking about comets a little bit here. We did talk about comets. We really shouldn't have them. If the universe is billions of years old, they should have deteriorated a long time ago. I mean, they should have been gone within 10 to 12,000 years. If they formed millions or billions of years ago, they shouldn't be here. So where do they come from? Well, they invent things like the Oort Cloud, which is basically a fictitious comet nursery out in outer space that is so far out we can't see it. But this cloud, it was named after this gentleman that proposed it, named Oort, a Dutch astronomer, and he thought that there was some cloud out there that was just spitting out comets, and somehow they would end up coming to Earth. Okay, is there any reason to believe this? I mean, is there any evidence of this at all? The problem with this, or one of the big problems with this, is, of course, these comets shouldn't be here. And secondly, we see that comets are observed to actually leave our solar system, but we have never, ever observed one entering our solar system. These would have all had to have come from outside our solar system. Again, it's just circular reasoning here. I mean, it's conclusions they have to come to because of their belief systems. To me, it seems like it's a convenient fantasy here. So here's the Oort Cloud. Basically, see what it proposes. Get a perspective of what they're proposing here with the theory. And again, we're taught this through evolutionary theory. The Oort Cloud is sometimes referred to as a comet nursery, where they're mysteriously born. So, so here's a look at this. In the view of our slide here, we see the sun in the middle, and the Earth is to the left of it there. And 1 AU means 1 astronomical unit, which is basically, they use astronomical units in measuring distances in outer space, which is the distance from the sun to the Earth. So, so we see the sun here, or the Earth is 1 astronomical unit away from the sun. So let's look out a little bit further here. Let's say we go out a ways. Where do they think this Oort Cloud is? Between 5,000 and 50,000 astronomical units out there. And this is where they think this might be. But astronomers have never, ever witnessed an incoming comet. Again, there seems to be strong reasons to not believe this. Is there more likely another source for where comets came from? I think the more likely source is they came from within our own solar system, and in fact from our own Earth. So could comets have originated from Earth itself? And again, this is a very significant question. To help us understand this, an observationally based scientific answer for the origin of comets we should first cover how objects fall into orbits of the gravitational field. And then we can understand how objects orbit each other. So let's say first you're standing on a tall mountain and you fire a cannonball. What would you expect the cannonball to do? Well, first it falls to Earth, right? Let's say we put a bit more gunpowder in our cannon. We fire it again. Yeah, it goes a bit further, right? Still falls to the Earth, right? If you could trace a path from the ball as you were standing there, you'll notice the arc shape. So as each successively faster shot, more and more matches the curvature of the circular shape of the Earth. If we now increase the speed of our cannon to shoot this cannonball out to 17,000 miles an hour, then the ball's falling arc would match the curvature of the Earth, and the ball would basically continue to fall completely around the Earth and never come down. And this is what produces a circular orbit. So it's going at enough speed where it remains in orbit, and its fall toward the Earth and its speed are equal, so it remains in orbit. Now, if the speed's higher than this, of course, it will go out of orbit. It'll go further away from our body. So this is how a circular orbit is produced. So here's a view quite a bit further out now. So here's our solar system, and with this green elliptical here, you'll see the sun here in the middle is this yellow dot, the large yellow dot. And the Earth is a smaller dot to the left. You probably can't see it on the screen, it's probably too small. And again, this isn't even to scale. But what would happen if we fire something from the Earth at a rate of speed higher than 17,000 miles an hour? If you could fire an object at that speed, it would enter into what's called an elliptical or egg-shaped orbit instead of a circular orbit, and it would travel far out from the Earth and slow down as it goes further away, eventually until it reaches a point where the sun's gravity starts to pull it back toward the sun again, and will bring it back and circle, or orbit the Earth. So this becomes this oval-shaped, elliptical or egg-shaped orbit. So they would actually not come back and orbit. Objects fired from the Earth at this rate of speed or higher would not come back to the Earth. They would just be captured by the sun's gravity instead, because the sun has so much higher gravitational forces than the Earth does. So the object would go, again, slower and slower as it goes further and further away, and then gravity eventually will start bringing it back. This far point that we see here is called the aphelion, which is the farthest point, and then you'll see it reach that point and then start to fall back toward the sun as it gets into that orbit. So we also can see that we can go out further than that. So we can get into a parabolic orbit that goes out. So there's a range of these orbits that will still capture these objects and still bring them back to the sun and orbit the sun. Faster than that, these objects actually will leave our solar system because there's too much speed for them to be captured by the sun. I guess that's where we need to leave off. We'll pick up there. I'm hoping that we pick up again in January. There's still a little not sure about the class as far as when we want to pick up again, but I'll take my normal 3-month break and then be back and we'll continue this discussion. So any questions anybody has? Thank you. Appreciate it. You're welcome.